All right, so let's look at this problem here. We have an athlete whose event is the shot put releases a shot. When the shot whose path is shown by the graph to the right, here's our graph. Okay, so I'm going to zoom in a little bit here. And notice that the horizontal axis, the x-axis, is the shot put's horizontal distance, and the y-axis is the shot put's height. So we're going to come back, refer back to this particular diagram. So we have here, it says, is shown by the graph to the right, is released at an angle of 40 degrees. Its height, f of x, in feet can be modeled by this equation. F of x is equal to negative 0.01x squared plus 0.8x plus 5.2. So let me zoom out a little bit. There we go. Where x is the shot's horizontal distance in feet from its point of release. So part A, it says, what is the maximum height of the shot and how far from its point of release does it occur? So we definitely want to answer that, and I underlined the maximum height because that's what we want to find. That's the first part of A. B, what is the shot's maximum horizontal distance to the nearest foot, tenth of a foot, or the distance of the throw? And part C, from what height was the shot released? Okay, so let's look at the first part. We're looking at the equation that's given. F of x is equal to negative 0.0x squared plus 0.8x plus 5.2. Now keep in mind, this section here, we were talking about parabolas. And you notice that this diagram is in the form of a parabola where it's facing down. Okay, so it opens downward. And we know our leading coefficient is negative 0.01. So this is what we want to see. Is in the shape of a parabola. So we want to find the maximum height. So as we look at our diagram, we want to find what this is actually, its height there. Okay, so let's take this equation and notice that since we want to find the maximum height, then we want to find the ordered pair. That's what we're looking for. So what would be the ordered pair? Now remember, we use the to find the maximum height, okay, or the minimum. Okay, if we want to find the max or min, we would use the formula to find the vertex, meaning to find the x coordinate. And we would use the formula negative times b all over 2a. X is equal to negative times b all over 2a. So we have our b, which is 8. We have our a, which is negative 0.01. So we're going to plug it into our formula. We have negative times, and this should be 0.8. Sorry about that. We have 0.8. So our b is going to be 0.8. I wrote the equation incorrectly. And then our denominator, we have 2 times negative 0.01. So we have negative 0.8 all over negative 0.02. Okay, so then we have here negative 0.8 divided by negative 0.02, which gives us 40. Okay, so it says how far from its point of release does it occur? Well, we saw that in the diagram. Okay, the distance is 40 feet. So we answered the second part of A, how far from its point of release does it occur? But we need to answer how to find the maximum height. So what we're going to do, we're going to take our x coordinate, which is 40 feet, and we're going to plug it back into this formula for x. So at 40, meaning we have our x coordinate, find the y. We have negative 0.01 times 40 squared plus 0.8 times 40 plus 5.2. And then you're going to have 40 squared, which is 1600, times negative 0.01. That would give us negative 16, plus 0.8 times 40 is 32, and then plus 5.2. And we add those together. Negative 16 plus 32 is 16, plus 5.2. That gives us 20.2. Okay? So the maximum height is 21.2 feet. This is the maximum height. And it occurs at 40 feet. So we've answered part B. Okay. So the next question is asking us, it says, what is the shot's maximum horizontal distance? Okay, we found the height. Now we want to find the maximum horizontal distance. We know it's at a 40-degree angle, but what is its horizontal distance? So let's work that one out. So to find that, what we're going to do is use the quadratic formula. And you all know the quadratic formula. So for part B, we're going to use the quadratic formula. So x is equal to, so we know what A is, B is, and C. So let's plug it into the formula, and you all know the formula by heart at this point. So x is equal to negative times 0.8 plus or minus the square root of 0.8 squared minus 4 times negative 0.01 times 5.2 all over 2 times negative 0.01. Okay, so out before the plus minus, let's multiply negative and 0.8. We have negative 0.8 plus or minus the square root of square 0.8, which would give us 0.64. Then we're going to multiply negative 4 to negative 0.01 to 5.2. And we have here plus 0.208 all over our denominator, 2 times negative 0.01, which is negative 0.02. Add 0.64 plus 0.208 under the radical sign, and we have 0.848. Okay, and then all over negative 0.02. So I'll leave it up to you to go ahead and work the work the both solutions, but I'm going to give you the solutions to um, this example. So let's take the square root of 0.848. So it has an approximation of 0.9208691. Okay, so we have two solutions, negative zero point 0.8 plus the square root of 0.848 all over negative 0.02. And we have our second solution, which is negative zero point 0.8 minus the square root of 0.848 all over negative 0.02. So now if you want to, you can plug in where you see the square root. You will write, put or here. I'll let you calculate everything, but I'm going to give you the solution to it. So our first one, negative 0.8 plus the square root of 0.848 all over negative 0.02 gives us negative 6.04. Okay, and then our second equation, negative 0.8 minus the square root of 0.848 all over negative 0.02, which gives us 86.0. Okay, so one of these we will have to reject, because if you look at going back to our diagram and we're talking about our, what's that again? Let's go back to that question. We're talking about the horizontal distance. There is no way that we're on the negative side of the x-axis. We're on the positive side. So we can reject negative 6.04. Therefore, our solution to this equation, to this formula for it to answer the question, the maximum horizontal distance is 86.0 feet. Okay, so that is our, let me write it down, maximum distance, horizontal distance. Okay, so that was part B. So this is a pretty long question, but we can get through this one. Now let's look at C. From what height was the shot released? Meaning, at 0, what was the height at 0? So going back to our original equation, because it says from what height was the shot released? Well, it was released at 0. So when x is 0, so we're going to go back to our equation. And where we see x, we're going to plug in 0. And we know that this will give us 0 plus the second term is 0. And then we have plus 5.2. Add those together, 5.2 feet would be the height when the shot was released.